goodness of fit. That is, I have one distribution. I know how it's supposed to look. Does it fit? One thing, does it fit with what it's supposed to be? This is not, it's supposed to be anything. It's how well do they fit together. So one is like I have one sample and I have like a target. I want to know if it's meeting that target. That's goodness of fit. How well does it fit what it's supposed to? Homogeneity is, are these things distributed the same? So you're going to always have more than one sample. And they give it to you in like this matrix form. We're going to use matrix in our calculator to do the problem too. So this is kind of what I just talked about. I don't need to go through this much, but the same idea. Um, if the female and the male distributions are homogeneous, it would be the same percentage of people lived with parents in apartment and dormitory. But so don't look at the totals. That looks fine. Like those look similarly distributed, right? Like the same percentage in with parents in an apartment. But then that makes me think, okay, they're probably not. So, because that's pretty far apart from each other, you know. So HO would be, so this is, there's no difference in distribution of living arrangements. For males and females. And then HA is there is a difference. So HO, we always start off like things are equal, right? So we say there's no difference, things are equal, and then we try to disprove that. There is a difference in the distribution. Of living arrangements for males. I feel a little bit sexist right now because the chart says females first and I put males first. I apologize. So this would be like there is no difference between the distribution of AP scores between stats, calc, and physics, and then there is a difference in the distribution between stats, calc, and physics. All right, turn the page. So the way you find the expected, so expected kind of assumes that they are equal, and you go through this calculation, and the calculation is the row total times the column total divided by the total, like the whole thing. So like that's your total. So we're gonna go through and do that for each slide. So the good news is when you do like the long, the good news is your calculator does this. It's like kind of long and tedious, so you really only want to do it if you're doing like multiples. So if I do all six, I would throw my calculator. But you do have to do it individually because it'll be like a multiple choice question, like find the expected value for that slot, and you don't necessarily want to type everything in. So if I'm doing like with parents female, the column total is 133. With parents female is right there. So and then the row total is 150. So it's 133 times 150 divided by the total, which is 350. Let's figure out what that is. chi-squared thing, what we'll do is subtract those, square it, divide by the expected, and then we add up. There's that sigma, so we're adding up all those differences. So the bigger the difference is, the more it's going to contribute to that overall chi-squared. The bigger the overall chi-squared is, the more we're likely to call them a liar. So we can just, I'm going to do a couple. I think I've seen this at some point, but do like this one and this one. Let's just make sure we're getting the same thing, and then I'll show you how to throw in the calculator. Did you just rage quit sharpening your pencil? Do you need a pencil? What? You guys are stocked up? So here I got 24. And here I got 91.43. You want what? Oh, 161. Typed it wrong. 92 straight. Okay. Thank you. They can be decimals. They don't have to be regular integers. Is that okay there? Okay. The chi-squared statistic, we wrote this down before. I'm just writing it down again. So it's observed minus expected squared divided by expected, and then this summation means that we're doing that over all 6 of those slots and adding up all the errors or the differences. The degrees of freedom, so we'll get back to that. Degrees of freedom, so it's been n minus 1, categories minus 1. Well, there's 2 variables in this one, so their degrees of freedom is different. So it's rows minus 1 times columns minus 1. So like in this example, this is a 3 by 2. Actually, I forget. Is that 3 by 2 or 2 by 3? I think it's 2 by 3. It's rows by columns, right? 2 by 3. So the degrees of freedom would be 1 times 2, so your degrees of freedom would be 2. Like you knock 1 off the rows, 1 off the columns, then you multiply together. The p-value, and I'm going kind of quickly through this because it's the same stuff from Monday. P-value is going to be chi-squared CDF. You put the chi-squared statistic in that you found, and you want to always shade above that for chi-squared because you're adding, so it's always going to be a positive number. It gets bigger and bigger. So we're going from chi-squared to infinity, and then we tell the calculator the degrees of freedom, which is that rows minus 1 times column minus 1. Let's just jump to the actual problem. So just go to this one. Is there a difference in the distribution of personality types among certain college majors? So I think we know enough to just go ahead and do one. See how it goes. So I'm going to do a chi-squared homogeneity. Remember, you got to label it. And if you called this chi-squared goodness of fit, you would lose points. You'd lose a point. Goodness of fit can only have one data set. So we got 1, 2, 3 here. So HO would be there is no difference in the distribution then our conditions, so randomness. So I need independence, that's the less than 10% thing. I've got 440 students, so I have to assume that 440 is less than or equal to 10% of all the college majors, I guess, or college students. And then each expected has to be greater than or equal to 5. But we're not going to be able to show that until we do our table, so I'm putting like C below. There's my conditions. Okay, so what you have to show is the expected matrix. Um, let's put it in the matrix first. That might be a better order to do it in. So did you guys do matrices in like pre-calc or advanced algebra? So you've used matrix before. People in pre-calc now, have you gotten the matrices yet? Yet? Nope. Probably?
If you say problem.
We don't know the words. Just show it and then we'll see.
Oh, okay. Have you done that?
Yes.
Do you agree that we probably we've maybe done that? Okay. All right, hit second matrix, which is like second and then the x to the negative first. So you should see that screen. Any problems yet? I'm waiting for an error.
Was this like yeah, we did like the we used this to like
It's like row reduce and solve
yeah.
systems.
Yeah, it's
Yeah.
system of equations, yeah.
Yeah, yeah, okay.
Please go through this again though inside.
Oh, for sure. I was just curious if you'd like seen it before. Okay, so we're gonna go to edit, and I'm gonna put in the observed matrix. So the observed matrix is this. It's what I saw. It's what I actually have. This. So that is a. Remember, you don't worry about the like. You're not putting the totals in there. So that is, I believe, and we'll find out in a second. That's a 3x5. So I'm gonna type 3x5, and then it'll pop up with a 3x5, and I'll find out if I'm correct or not. So that, yeah, that's right. And then you're gonna put in the numbers. So you're literally just typing in that table.
With the totals.
No, no totals.
Because it'll do the totals by itself.
Right. Yeah. I was gonna say the calculator can do the totals by itself, but I didn't know if that would sound sarcastic or not, so I didn't. So then we're gonna run the test, and the calculator is gonna go through and do that rows times columns divided by total for every slot, and it's gonna give us the expected matrix. So we're not gonna have to do those calculations. Because that'd be like 15 times doing that. That'd be really annoying, right? So hit stat, go to tests, and this is just a chi-squared test. So it's not the goodness of fit. That's what we did Monday. That's with like one sample. This is multiple samples. You're comparing them to each other, so that's not goodness of fit. The observed I put into my matrix A. And what this is saying, it's not saying where is the expected, like where did you put it? It's saying where do you want me to put it? So it's gonna put the expected values in matrix B. It'll override it. I'm pretty sure. So hit calculate. Awesome. Oh, I put it in. I put my first matrix in C. Did it work for you guys?
Yeah.
Okay, so it's my fault. My problem. 14.4. B value is 0.072, let's say. But I still have to write down the expected matrix. So so we gotta see it. So go back to matrix, so hit second and then the matrix button again. And if you go to matrix B and hit enter, it'll pop up here. And then you can kind of scroll. I really wish you could like round it to one decimal place instead of as many as I have. But that's the other way. So you can do it that way too. Is it friendlier that way?
Way better.
So go second matrix, go to B, go to edit B, instead of just like hitting enter. So that looks a little cleaner. But your job is to write down all those. So I'm going like business, engineering, communications, open, conscientious, extrovert, agreeable, neurotic. It says ocean. You can round, don't write down all the decimals.
Yeah, because put R question mark.
So I got a couple things to clean up after that, but I'm pretty much done.
Does it really matter how we round it?
Not really. I wouldn't do like 30. I'll put at least one decimal place. But you don't need to put like 4. Did everybody get the same number? Is that like that worked for everybody? Amazing. That never happens. Good job.
So what are we gonna do? Use a calculator. That never happened. You got 30. Mike got 30.
I mean, it might have been like 8, 8, and I just wrote 8. I wouldn't worry about it. Or like I typed the number in, one number off, or you did, or as long as you know like how to get to it. So, two things. I've written this matrix down and I have not said like what it is. So I'm gonna put over here like, hey, those are the expected values. Because up there at the top I said each expected value is greater than 5 or equal to 5. I said see below, so this is me saying like here they are. Look, all of those numbers are greater than or equal to 5. And then this number I have to justify. I know you got it from the calculator, but same as before, I have to like show them that I know how to find it. So that's the chi-squared CDF. And you put the chi-squared value, so the 14.4, and then 99999. And if you try to type that in, it's going to give you an error. Because you're missing degrees of freedom. What are the degrees of freedom in a 3 by 5? 2 times 4, so 8. Good. And then I'm going to put DF so they know that. I know that's the degrees of freedom. But I don't even have to put 0.072 because it's already there. And I'm done except for a conclusion. response on the back, and then there was a part B that said like, does this support the council person's beliefs or whatever? And some people just wrote this and didn't put anything for part B. And I don't know if you didn't see part B or if you thought that this conclusion like answered part B. So I just want to point out if there is a part B where they ask, like, you need to reiterate. Because otherwise, like, they don't know exactly what they're supposed to grab from here. So you need to follow up and say yes because of this. So if you miss a point on the back, that's probably why there were like 4 of those or something. Questions on that one anywhere? We got loads of time.
13 whole minutes.
Wait, oh yeah, okay. There's one on the next page. I want you to try that.